These are notes 2.1, classification of matter. And in your textbook, you need to read pages 38 through 49 and 170 through 179. This is all in your Canvas login. So if you go to Canvas, you'll see those pages. The study guide pages are 13 through 16 and 71 and 72. All right. So by the end of this section, you should be able to describe three states of matter, the three states of matter, their attractive forces, and the relative spacing of particles in that phase of matter. You should also be able to categorize matter into mixtures and pure substances, categorize pure substances into elements or compounds, describe the general organization of the periodic table, describe similarities and differences between elements in the same groups and periods, identify the diatomic elements, and start identifying common elements by name, symbol, and position on the periodic table. All right, so that's a lot. So let's get started. Well, first, let's talk about our mental model of matter. That's hard to say. Matter is made up of tiny little particles called atoms or molecules. And these particles are always in constant motion. They're always moving. We talked about the Kelvin scale, and you may have heard the term absolute zero. That's the lowest measure on the Kelvin scale, absolute zero. What that means is that that is the point at which all matter, all motion stops. Okay, it's just theoretical. It's never been reached before. We've gotten as low as like 2 or 3 degrees Kelvin, but never zero. So it's just a theoretical temperature. Right now, the higher the temperature, the greater the motion. So as we heat up molecules, atoms, they move faster. And there are attractive forces between the particles that determine whether the substance is in a solid, liquid, or gas. So let's look at that. This is classifications of matter by state. So this is a solid. You can see the little atoms there in a solid. They're all very, very close together, if not touching. And they are in a pattern. So this solids have a fixed shape. So think of a solid like, a cube or a rock or the table, okay? It has a fixed shape. It doesn't change its shape unless we do something to it, like cut it or something like that. It has a definite volume. It is the highest density of the three phases. And there is a strong attraction between the atoms or molecules that are in that substance, a strong attraction that holds them very close together. Liquids have no fixed shape. So think about a glass of water there. It gives the example, and it shows the molecular arrangement of the water molecules. There's no fixed shape. So whatever you pour the liquid into, whatever container, it's going to take the shape of the container. But it does have a definite volume. It does sit at the bottom of the container because of gravity, and it has a definite volume. That volume doesn't change. The density is in the middle of the three phases, and there's moderate attraction between the molecules. Now, they're not packed together and lined up like a solid, but there is a little bit of attraction between those molecules. Then we have our gas. Our gas has no fixed shape and no definite volume. So you can see there that the jar that has the gas molecules in it, you can see that there's a lid on that, because if we were to take the lid off, then the gas molecules would come out and start filling the room and take the shape of the room. It doesn't have a definite volume. So these would, you have a jar there that's what, a liter jar. You take the lid off and the molecules and atoms start coming out and fill up the room. So you went from 1 liter to however many liters the size of the room is. The molecules just move apart. It is the lowest density of all three phases, and there's very weak, if any, attraction between the atoms and molecules that are in a gas. So what you'll see is if something is in a gas, is the atoms and molecules are very far apart like that when you look at illustrations, and it has that tracer behind it. What that tracer means is that those are in very fast motion. They're moving constantly. So those are your three phases: solid, liquids, and gases. So classification of matter. We have a organizational tree here, and the way you read this is all matter is either a pure substance or a mixture. So we have to decide if it's a pure substance or a mixture. Okay, so if it is a mixture, which means that it has atoms of different types or molecules of different types mixed together, then you're going to go to the right. And there's only two types of mixtures, heterogeneous and homogeneous. Now, last year when you're studying biology, you talked about homozygous and heterozygous genes. Homogeneous and heterogeneous. Hetero means different. So when you look at a heterogeneous mixture, it looks different. Like, for example, sand and salt water. So you can tell the difference between the sand and the salt water when you look at it. You can see, sand floating around in the water, or, you can go to the beach, and when you pick up some sand, the water comes through your fingers, but the sand stays there. So you can tell the difference between, just by looking, you can tell the difference between the two components of that mixture. That's heterozygous, different components. Okay, and then you have homogeneous. I'm sorry, did I say zygous? Heterogeneous. Then you have a homogeneous mixture where it looks the same, like a cup of tea. Now, you know that there is things in that water to make tea, but it's all brown. It's the same throughout. So you can't physically look at that tea and say, oh, well, there's a molecule of tea and here's a molecule of water. So we see the molecular illustration down here where we have these red and white ones, like right here. That's your water. But then you have these big molecules here. This could be the sugar that's in the tea, or this could be the actual chemical that's in the tea. But just looking at that tea, you can't physically pick out the difference. So that's going to be a homogeneous mixture. Okay, so those are mixtures. Now, matter can also be pure substances. So let's talk about pure substances. Pure substances are either elements or compounds. So if it's a pure substance and it's an element, it's going to be something from the periodic table. There's only one type of atom that makes that up. So here the example, they're using the Goodyear blimp, and inside the blimp, they have helium. So you see all of these little atoms here are all helium atoms. That's an element. We can find helium on the periodic table. It's element number 2. Okay, and if it's a pure substance, but it's not an element, it could be a compound. So we see here a good example of this compound is water. So we can have pure water, which means that in a container, in this glass, there's nothing but water. It's water and there's nothing else there. So the example here, the molecular illustration, you see all of these water molecules. There's nothing else in there but water. Okay, so matter is divided into pure substances or mixtures. Pure substances are elements and compounds, and mixtures are either heterogeneous or homogeneous. All right, so let's talk about the periodic table. There's some major divisions on the periodic table that we need to talk about. And the first major division is that the periodic table is divided up into metals and nonmetals. So we see here at the top, this brownish color, these are all the metals. And then the lavender are the metalloids, and then the nonmetals are green. So this stair step, if you look at any periodic table, you're going to see this very dark line that starts up here at boron and then goes down stair stepping through the periodic table. That is the division line between the metals and the nonmetals. So all of these on the left of that stair step sign are the metals. All of these on the right of that stair step are the nonmetals. Now we do have things called metalloids, and these are the lavender ones that are touching the stair step, except for aluminum and polonium, because they have characteristics of both metal and nonmetal. That's why they call them metalloids. So they're right in the middle. That's that area that divides the metals and nonmetals. Okay, but two major divisions of the periodic table are metals and nonmetals. Okay, so let's look at some characteristics of metals and nonmetals. Some properties of metals are that they're shiny, they conduct electricity, they allow electrons to flow through them, An electron is a subatomic particle of the atom, and they're malleable. Now, malleable means that you can hammer the metal into thin sheets. That's what malleable means. Think about a blacksmith. What is the hammer called that the blacksmith holds and bangs the metal with? It's called a mallet. Okay, so think of the blacksmith hammering the metal. It's malleable. Okay, all metals are to the left of the stair-step line on the periodic table. All right, nonmetals to the right of the stair-step line on the periodic table. Their properties are they are brittle, dull in appearance. They're insulators, which means they do not allow electrons to flow through them. And if you were to hit a non-metal with a mallet, then they're brittle, so they're going to shatter apart. Okay. One property that I'm going to add over here with malleable is that metals are also ductile. So let me go ahead and add that in. Ductile means that you can pull or stretch the metal into wires. So you can bang it into sheets and you can stretch it or extrude it into a wire. Okay, so those are properties of metals and nonmetals. All right, so if we look at the periodic table again, we know the left side are metals and the right side are nonmetals. There's a special group right here in the middle, and in this picture of the periodic table, it's colored in light blue. These are called the transition metals, and they do very weird things. So normally, most of the time when we give rules for the periodic table, we're just talking about the main group elements. So the main group elements here are going to be the ones in light beige. So it starts over here with this group, that's hydrogen. Then we go to group 2 here, and then we're going to skip these transition metals. We're going to talk about them at another time, give them their own time that we talk about them. And we're going to skip way over here to 13 or 3A through 8 or 18. So these are the main group. When we talk about trends and rules of the periodic table, we're mainly talking about these main group elements. We'll talk about transition metals at another time. All right, so the periodic table. There's many scientists who worked on the periodic table and worked on developing the periodic table. There's a couple that they talk about when you do your reading in the book. But Dmitry Mendeleev is the scientist who is given the most credit because he came up with explanations about the periodic table. So Dmitry Mendeleev, he's Russian, and he is known as the father of the periodic table, as he was the first to publish a table arranging the elements by increasing atomic mass. So he arranged the table according to atomic mass. Okay. And through the observation of their properties, Mendeleev's version of the periodic table would later be revised. And it's revised by a British gentleman named Henry Moseley. So Henry Moseley is known as the father of the modern periodic table. That's the periodic table that we use right now. This version of the periodic table was rearranged from what Dmitry Mendeleev used, and it was arranged by increasing atomic number instead of atomic mass. So we're going to talk about the difference in atomic mass and atomic number here in just a moment. This is based on his discovery of the actual nucleus or the nuclear charge of the elements. All right, so the organization of the periodic table. Blank are the horizontal rows, left to right. So here we have these 2 elements that are on a row together. Then we have these 8 elements that are on a row together, and these 8 elements, and then these 18, etc. So these horizontal rows are called periods, and that's where the periodic table gets its name. because by the time you get to the end, the properties start repeating back at the beginning. So periodically, they start repeating properties, and we have to start back over here on the left. So that's why it's called a periodic table. Okay, and there are, how many periods do we count? 7 periods on the periodic table. All right, so an example would be 2 elements that are on the same period. Okay, you might not have picked these 2, but hydrogen and helium. So hydrogen's number 1 and helium's number 2. They are on the same period. Okay, so periods go across horizontal rows on the periodic table. All right, so vertical columns are the up and down columns on the periodic table. These are called groups or families. Now, the old name of them are families. So the modern word that we use to describe these are groups. Now, you may hear some people who have been in the chemistry field for a while call them families, but the new term that I use and that you should start using are groups. And these are the vertical columns up and down. Okay, and there are 18 groups on the periodic table. Okay, and examples, blank and blank are in the same group, hydrogen and potassium. So if we look at group 1, hydrogen is at the top. Potassium symbol is K. So if you look down to the 4th period in group 1, you're going to see K. That's potassium. They're in the same group. All right, and elements in the same groups have similar blank and blank properties. Okay, so remember what we said. They have the same physical and chemical properties. All right, and so let's look at these groups. Hydrogen, lithium, sodium, and potassium, the first 4 here in group 1. Okay, with the exception of hydrogen. Now, there are exceptions. Hydrogen is one of those weird elements that don't really, sometimes it acts like a metal, sometimes it acts like a non-metal. So it's one of those weird ones. But lithium and sodium, here you see a picture of lithium and sodium. They're both solids. They're shiny. Okay. When you cut sodium, it's immediately shiny, but really, really quickly, like within a few seconds, it gets this white coating on it. Sodium oxidizes really, really quickly and gets this dull appearance on it like that. But they're both shiny. Lithium gets this dark oxidation color, but you can still see it shiny. So they have the same physical characteristics. Okay. Now over here we have fluorine, chlorine, bromine, iodine. These are in group 17. And we can see here's a comparison between these two. You can see that iodine starts out as a solid, but very quickly goes into a gas. It changes phases into a gas. So you can see here that they're very, very similar in their properties. Okay, so make sure that you know that the groups have the same physical and chemical properties. That's why they're in the groups together, the up and down groups. All right, so this is the same activity that we did yesterday, I think, or the other day in class. We're talking about the different groups. Different groups have different names. Okay, so we have here, let's do the metalloids first. So these are the metalloids that, right here, the stair-step line. These metalloids are the ones that are along the stair-step line, except for aluminum and polonium. Okay, so those are the metalloids. And then we have our alkali metals here. This is group 1. Group 2, the alkaline earth metals. Okay, and then we have our transition metals, which is this group, this big group that's kind of bumped down here in the center. Okay, and our noble gases are on this far edge here. Those are the noble gases. And then we have our halogens that are next to them, right there. And then our chalcogens, which are these three right there next to them. Okay, so make sure you have that colored in your activity sheet that we did. You're going to need to know the names of these groups as well for your next test. All right, so let's talk about atoms. On the periodic table, you're going to see all periodic tables have this type of information that's on there. So what I've done is I've taken this beryllium that they used here, and I've enlarged it just a little so that we can talk about what these different things are. So first of all, this number at the top is the atomic number. That's the atomic number, and the periodic table is arranged by increasing atomic numbers. So if we look back at the periodic table, hydrogen is 1, then we have helium is 2, and then lithium is 3, 4, 5, 6, 7, 8, 9, 10, and then it starts over here 11, 12, 13, 14, 15, 16, 17, 18, and then it goes to 19, etc. So that's the atomic number. The atomic number is the number of protons that are in the atom, positively charged protons that are in the nucleus of the atom. So what I've done is I've taken beryllium here, and in the nucleus, the center, these black spheres I use to symbolize the protons. So though it has 4 protons in the center of beryllium. Now, what's not on this periodic table here, none of this, is the atomic mass. So the atomic mass for beryllium is 9. Well, for the one form of beryllium is 9. So if we take 4 protons, okay, and if it has a mass of 9, that must mean that the other 5 masses come from something else. So these red spheres or circles here are the neutrons. So in the nucleus of every atom are protons and neutrons. Okay, and this number tells you the protons. So you take the mass and subtract this number, and it tells you how many neutrons. So beryllium has 5 neutrons, 4 protons for a total mass of 9. So each one of these particles has a mass of 1. It's called an atomic mass unit of 1, an AMU of 1. So you have your protons and neutrons in the center. Now, for most atoms, okay, the atomic number tells you the number of protons that are positive, but the electrons are the little bitty particles that zip around, and they have relatively no mass. It's so little mass that their mass is like 0. They say it's 0, but it's not actually 0 because it does exist. It's just negligible. These electrons are negatively charged. So for every positive proton, you've got a negative electron. So these cancel each other out and make these elements neutral, no charge. Okay, so if this has 4 protons, then beryllium has 4 electrons. And this first ring here has 2 electrons on it. That's all it can hold on that first ring. So the other 2 electrons are found on the second ring that is around beryllium. Okay, now we can add or subtract electrons. And when we add or subtract electrons, it's called an ion, I-O-N. So an ion is an atom that's gained or lost electrons. So this unit 2 has a lot of vocabulary in it. So make sure that you're writing these vocabularies down, like groups, periods, ions, protons, neutrons, electrons, all of this stuff you need to have written down. So if we add electrons to an atom, like I just added this 1 electron, I took it off and add this 1 electron here. So now beryllium has 4 positive charges, but now it's got 1, 2, 3, 4, 5 negative charges. So if each one of these positive charges cancels a negative charge, if we've got 4 positive and 5 negative, the overall charge of this beryllium now is a -1. Okay, and that's what's called an ion. It's got a charge of a -1. If I were to add another electron over here, now it would have a charge of -2. Okay, but we can also go the other way. So here we have back to the neutral, 4 electrons, 4 protons. If we were to take off an electron, okay, now we've got 4 positive and 3 negative. So now this atom has a positive 1 charge. And if I were to take another one off, now it's got a positive 2 charge. Okay, so it's simple math. You're just adding or subtracting electrons. Okay, and you're seeing what's canceled out and what's not canceled out. So that's where you get those charges. Okay, and those two different types of ions, positive and negative, have a name. They're called cations and anions. Cations are positive, and the way you can remember that is because cats have pos. Okay, positive ions are called cations. Anions are negative. Don't say anions. That's not how you pronounce that. It's anions. Anions. They're negatively charged ions. All right, so remember, the number of protons determine which atom that you're talking about. And as you just learned, atoms of the same element can have different numbers of neutrons. We can add or subtract neutrons just like we can add or subtract electrons. Okay. We haven't talked about what it's called if you add or subtract neutrons. We just talked about electrons. We're going to talk about the neutrons in a minute or in another time. All right, so we're just going to concentrate on changing the number of electrons now. Atoms that gain or lose electrons are called ions. And there are two types of ions. They're cations and anions. All right, so here we have calcium plus 2 or 2 plus. You can switch the positioning of this plus sign. It can either come before or after. So if an element does have a charge like this, then the charge is going to be written as a superscript number right up here in the upper right corner. Okay, so this is calcium plus 2. Now that you know what a cation is, describe what the plus 2 above the calcium indicates. So if it's calcium plus 2, what does that mean? It means that it lost 2 electrons because the protons are positive in the nucleus. We have 2 more protons than we do electrons, so it has a plus 2 charge. So that means that calcium lost 2 electrons. It cannot lose protons out of the center. If you lose protons or gain protons, it turns into a different element. Okay, so we don't gain or lose protons, so we have to gain or lose the electrons to get the charge, the things on the outside of the atom. All right, and so for the anion, which is nitrogen, it's got a negative 3 charge. Now that you know what an anion is, describe what the 3 minus above the nitrogen means. So what does this 3 minus mean? It means that it gained 3 electrons. Since electrons are negative, it gained 3 extra electrons. So it's a negative 3 now. All right, and so here's a check for understanding. Place a circle around the anions and a box around the cations. So remember, what charge are anions? Anions are negative, okay, and cations are positive. So this one, sodium, the first one. Okay, so you don't see any number here in the upper right-hand corner, so that's neutral. It's neither positive nor negative. All right, so negative 2, is that an anion or a cation? All right, that's an anion because it's negative, so we'd put a circle here. Positive 3, that's a cation, so we'd put a box around this one. Okay, plus 1, does that get a box or a circle? Yeah, box. Terrible at drawing boxes with the mouse. All right, negative 3, a circle or a box? Circle, right, it's an anion. Krypton, no charge, is neutral. Lithium, plus 1, box. Manganese, no charge. Selenium, -2, anion. Strontium, no charge. Barium, +2, it's a cation, it gets a box. And bromine, -1, it's an anion, so it gets a circle. All right, so part 2, determine the number of protons, neutrons, and electrons for magnesium +2. Well, let's look back at the periodic table. Magnesium is right here. Okay, so 12, that tells us the number of what? Protons. So magnesium has 12 protons. Okay, and that's the symbol for proton. All right, so we don't know the mass of magnesium, but if we were to look that up on the periodic table, I'm pretty positive magnesium is a 24. It is 24. So if we have 12 protons and the mass is 24, how many neutrons do we have? We'll take 24, subtract 12 from it, and you have 12 left over. So we have 12 neutrons. Okay, and the symbol for that is a lowercase n with a 0. 12 neutrons. And how many electrons? Well, this has a charge of +2. Okay, so what does that mean, a +2? It means it lost 2 electrons. So if normally it's got 12 electrons and it lost 2 electrons, then it would only have 10 electrons to give it that +2 charge. So electron is a lowercase e with the minus sign here. Okay? All right. So again, reading the periodic table, we've got the name here, carbon. We have the symbol there. Sometimes it doesn't include the name. The atomic number is above the symbol. And on this particular one, the atomic mass 12.001 is underneath. That's where they're going to put the mass on the periodic table. So if you look at the periodic table that's in the classroom, you're going to see all of the masses that are under all of the elements. Okay, and again, metalloids are those that are above and below the stair-step line on the periodic table. They have some properties of both metals and nonmetals. That's why they're called metalloids. All right, and the last part here, the diatomic elements. We dissect this word diatomic. Di means 2, atomic refers to atoms. So there are 7 elements on the periodic table that are considered diatomic elements. So when we look at a formula, like we're going to take water as an example because everybody knows that water is H2O. This little 2 here tells us that there's 2 hydrogens bonded to 1 oxygen. If it doesn't have a number there, that means 1. So this is 2 hydrogens bonded to 1 oxygen. So this little subscript number tells you how many atoms of the one that it follows that are in the formula. So diatomic means it has 2 atoms that make up this element. So the 7 diatomic elements are hydrogen plus these 6 here, and it makes a 7 on the periodic table. So if you look, it's nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Okay, and they all exist when they're by themselves, not bonded to anything. When they're by themselves, they exist as diatomic, which means they have to have a 2 there. So hydrogen has a 2, nitrogen will have a 2, oxygen will have a 2, fluorine, chlorine, bromine, and iodine. Now you have to know these 7 diatomic elements. The reason we call them the mighty 7 is because it makes a 7 on the periodic table, or you can use an acronym. I'm going to tell you what the acronym is that I use to remember this. So if you put H, NOF, CLBRI, horses need oats, 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 for clear brown eyes, and we use the I for eyes. So again, that's horses need oats for clear brown eyes. If you remember that little saying, that'll help you remember HNOF, CLBRI, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. All right, So that's it for Notes 2.1, and we'll see you in class. Remember, I'm doing all these on YouTube, so down in that lower right-hand corner, you're going to see the subscribe and like button. Please give me a subscribe and a like, and hit that little bell so you get notifications of when I post videos.